Think you know everything about our planet? Think again. We live on this giant spinning ball of rock hurtling through space. How much do we really know about it? We learn in school that it's the third rock from the sun. It's covered in water. It's home to, well, us. But our Earth is so much more complex, so much more wonderfully weird. It's a place of incredible extremes, hidden secrets, dynamic, ever-changing systems. It's a living laboratory, and we're all part of the experiment. Today we're going to peel back the layers of our home world and uncover truly mind-blowing facts. That will change the way you see the ground beneath your feet. Get ready. Your perspective shifted, your curiosity sparked, your mind expanded. Let's go. Alright, let's start with the basics. What shape is the Earth? If you said a sphere, you're close. For centuries, we've pictured our planet as a perfect round marble. It's in all the textbooks. But in reality, Earth is an oblate spheroid. In plain terms, it's squashed, bulging at the middle, like a water balloon spun really, really fast. Not a perfect sphere, a bit chubby around the equator. Why the bulge? Rotation. Earth spins over 1,600 kilometers per hour at the equator. That spinning creates centrifugal force. Same force when you're on a merry-go-round. Pole-to-pole diameter, about 12,714 kilometers. Equatorial diameter, about 12,756 kilometers. That's a difference of about 42 kilometers. So at sea level on the equator, you're about 21 kilometers farther from Earth's center than at the poles. This shape affects gravity. This shape affects satellite orbits. Next time you see a globe, useful but not perfect, the Earth is spinning and shaping itself. Now let's talk about something you can't see, but you couldn't live without: Earth's magnetic field. This invisible force field acts like a giant shield. It's also what makes our compasses point north. But here's the thing: that north is on the move. The magnetic North Pole isn't a fixed point on the map, it's wandering. Scientists have been tracking it for decades, and its movement has been accelerating. In the 20th century it moved about 10 kilometers per year. Recently it's picked up speed, 50 to 60 kilometers per year, heading rapidly towards Siberia. This isn't a random wobble, it's a sign of complex dynamic processes deep within the Earth's core. Why does this matter? Aviation, shipping, military navigation systems, they rely on precise magnetic models. World magnetic model has to be updated more frequently than ever. Without updates, planes, ships could be off course. Serious consequences. Geological history shows the field doesn't just wander, it flips. Magnetic North Pole, magnetic South Pole have swapped places hundreds of times. We're long overdue for another reversal, making power grids, satellites more vulnerable to solar storms. It's a powerful reminder our planet is constantly in flux, right down to its very core. When you think about what makes oxygen, what comes to mind? Trees, right? The Amazon rainforest is often called the lungs of the planet. But what if I told you most of the oxygen you're breathing right now didn't come from a tree? What if it came from the ocean? It's true. Somewhere between 50% and 80% of the Earth's oxygen is produced by marine life. The real heroes are tiny microscopic organisms called phytoplankton. Single-celled plants drifting in the sunlit upper layers of the ocean. They use photosynthesis to convert sunlight into energy. They consume carbon dioxide. As a byproduct, they release vast quantities of oxygen. Tiny, but their numbers are staggering. There are more phytoplankton in the ocean than there are stars in the Milky Way. Every other breath you take, you owe to these ocean drifters. They form the base of the marine food web, up to gigantic blue whales. The health of our oceans is directly linked to the air we breathe. So protecting oceans isn't just saving whales and dolphins, it's protecting the source of the air in our lungs. Look up at the night sky. You see one moon. It's been our constant companion for billions of years, controlling our tides, inspiring poets, lighting up our nights. But what if I told you that, for a time, Earth may have had a sibling moon? A second, smaller moon sharing the sky. This helps explain a major lunar mystery: why the two sides of the moon are so different. The near side, relatively low and flat, covered with vast, dark plains called Maria. The far side, we only saw it in the space age, is rugged, heavily cratered, and has a much thicker crust. The two-moon theory offers an explanation. A Mars-sized object, Theia, slammed into early Earth. The impact debris didn't form just one moon. It formed two. A smaller moon, about 1/3 the diameter, became trapped in Earth's gravity. It shared an orbit with the bigger moon for tens of millions of years. Imagine looking up at a sky with two moons. Eventually, the dance ended. The moons drifted apart. The smaller moon went on a collision course, but it wasn't a high-speed crash. Instead, it was a slow-motion cosmic splat. The small moon pancaked onto the far side of the larger moon. Too slow to make a huge crater, it added thick new crust. That pileup explains the far side's thicker crust and mountains. We may only have one moon now, but it might wear the remains of its lost twin. If I asked you to name the hottest place on Earth, what would you say? Most people would probably guess the Sahara Desert. Or maybe Death Valley in California. And Death Valley does hold the record for the highest air temperature ever recorded. A blistering 56.7 degrees Celsius. That's incredibly hot, hot enough to cook an egg on the pavement. But we're talking about the hottest spot, and for that, we have to look at the ground itself, the surface temperature. The title for the highest surface temperature ever recorded goes to the Lut Desert in Iran. This vast, arid landscape is one of the driest and most desolate places imaginable. It's a place of giant sand dunes, massive wind-sculpted rock formations called yardangs. It's so harsh that it's largely devoid of life. There's a reason it's called Dasht-i-Lut, which means emptiness plain. Using satellite data over many years, scientists from NASA have been able to measure land surface temperatures all over the globe. In 2005, a satellite recorded a stunning surface temperature of 70.7 degrees Celsius in the Lut Desert. More recent measurements have found spots that have exceeded 80 degrees Celsius, 176 degrees Fahrenheit. The dark soil and rocks soak up the sun's energy and heat up to extreme levels. So while you might survive the air temperature in Death Valley, touching the ground in the Lut Desert would be a very, very bad idea. How high does our atmosphere go? You might picture a blue line separating our planet from space, maybe 100 kilometers up, at the Kármán line. That's the boundary for aeronautics, where the air is too thin for conventional aircraft to fly. But the Earth's atmosphere doesn't just stop there. Not even close. It extends much, much farther out than most people realize. The outermost layer is called the exosphere. It's an incredibly tenuous region where gas is so thin that molecules can travel hundreds of kilometers without bumping into one another. The exosphere is mainly composed of hydrogen atoms, which are the lightest element. These atoms form a vast, fuzzy cloud around our planet. This cloud is technically part of our atmosphere, and it's called the geocorona. Data from an old observatory called SOHO, designed to study the sun, revealed the true extent of this hydrogen cloud. It extends an astonishing 630,000 kilometers away from Earth. The moon orbits us at about 384,000 kilometers. That means the moon is actually flying through the outer reaches of Earth's atmosphere. So when you see pictures of astronauts on the moon, they are technically not completely outside our atmosphere. Our planet's reach is far greater than it appears. Here's that final fact I promised you, and it affects something we all experience. The length of a day. We define our lives by it, 24 hours, a neat and tidy number. But that number isn't constant. A day on Earth is actually getting longer. It's all thanks to our beautiful, familiar moon. It's a story of gravity, tides, and a cosmic tug-of-war. The primary cause is the tidal interaction between the Earth and the moon. The moon's gravity pulls on the Earth, creating a bulge in our oceans, which we experience as high tide. But because the Earth rotates much faster than the moon orbits, this tidal bulge is dragged slightly ahead of the moon's position. This offset bulge tugs back on the moon, giving it an energy boost, causing it to slowly spiral away at about 3.8 centimeters per year. As the Earth gives energy to the moon, it loses rotational energy. This acts like a brake, slowing down our planet's spin. The result? Our days are getting longer by about 1.8 milliseconds per century. When the dinosaurs roamed the Earth, a day was only about 23.5 hours long. Go back 1.4 billion years, and a day was a mere 18 hours. The 24-hour day we take for granted is just a temporary state in our planet's long, dynamic history. So there you have it. From a squashed shape and a wandering magnetic pole to a lost twin moon and an atmosphere that embraces our lunar neighbor, our planet is not just a static rock but a dynamic, breathing, and constantly changing world full of secrets. Science is the tool that lets us peek behind the curtain and appreciate the sheer wonder of it all. The more we learn, the more we realize how much we still don't know. These facts are just the tip of the iceberg, a small glimpse into the incredible complexity and beauty of our home. It's up to all of us to be curious, ask questions, and protect it. Which of these facts blew your mind the most? Was it the ocean's deep breath, the true hottest spot, or the fact that a day used to be shorter? Let us know your favorite in the comments below. We love hearing what sparks your curiosity. And if you enjoyed this journey, make sure to hit that subscribe button and ring the bell. We have so many more mind-blowing scientific adventures to share with you. Until next time, stay curious.